Hello Math 152 students. In this video we're going to take a look at several topics out of 8.1, take a look at an applet, and address some StatCrunch issues. A lot of the vocabulary and problems in Chapter 8 are going to feel very similar to some of the things we did in Chapter 7 and then also with the binomial in Chapter 6. But what we want to do is set the foundation and see the difference and kind of see how Chapter 8 compares to our previous chapters. So we're going to hear a lot about the distribution of the sample mean in 8.1 and then the distribution of the sample proportion in 8.2. So we want to first of all clarify what we mean by a sample mean and the distribution of a sample mean. To set the stage, let's take a look at some context. Let's suppose we wanted to know the average salary in Catawba County. If you were doing this maybe as part of a project or an exploration, and you wanted to actually think about collecting this data, rather than maybe looking at several years ago data that someone had collected, you might want to consider, should I ask every person, right? Every single person. But why not? Maybe implying that that's not the best idea. But think about the advantages first. If we were able to poll every single person, we would have a census, not necessarily a sample. But the why not, this gives us some pretty big drawbacks. It's going to be expensive and maybe hard to do. It might be difficult to find every single person and ask them and get accurate information. So instead of asking every single person or doing a census, taking a sample makes sense. So let's say you decide to take a sample and you find an average salary. And it's not too important what the number is, but let's say that your friend Chelsea takes another sample and she finds the average salary a little bit different. So $57,014 compared to $56,948. Okay, so what's going on, right? Let's say you have another, going backwards instead of forwards here, guys, sorry. So Chelsea takes a sample, and then we have a third friend who takes a sample, and he gets an average salary that's lower. So if we wanted to know what's going on, you could probably provide some reasonable explanations. Your friends most likely sampled different people, not the exact same people you did, so it makes sense that the samples produced different sample means. So each of these three numbers represents an X bar, a sample mean that we collected from three different samples. So let's say this in a little bit of a different way. If every single one of you takes a sample, why do you all get different results if your samples come from people in Catawba County? Well, when we phrase it like this, your answer is because they're different samples. It seems a little bit obvious and intuitive at this point. What we're going to do is take that concept and translate it into any population and samples from any population. So we're going to talk about plotting these sample means and creating a distribution of those different sample means. We know we're going to get different values, and how are those different values distributed compared to our underlying population? So here's our key concept. What if, instead of plotting the population distribution, we plotted the means, all those X bars of everyone's sample? What would that look like? So to explore this idea, we're going to take a look at an applet. I'll show you how to get there from my math lab so you can do this as well, and try to illustrate the difference between an underlying distribution, or this population distribution, and then the distribution of these X bars, or the distribution of the sample means. So let's go into Blackboard. Here's my page. Let's take us into our Blackboard page. And then let's go ahead and click on your course content button. I know you can't see the end of that screen there, but if you scroll down in your course content, click on your My Math Lab resources and supplements, and look for your Tools for Success. If you click your Tools for Success icon, this will open up part of Pearson. And again, a little bit is cut off here, but you want to look for, in the review section, the applets. And I'm going to choose number 2, the sampling distribution. All right, so let me scroll up a little bit here. In this applet, you have the ability to select different distributions. I'm going to leave it as the uniform, the block distribution, because we recently discussed that in Chapter 6 and 7, or I should say more recently in 7. Then we have the option to look at several different statistics. I'm going to leave this as the mean and the median. We're actually really only going to focus on the mean. So the other thing that we need to do is choose a sample size. And when you're looking at the sample size, the box for that is right here. Let's leave it as a sample size of 2. See what happens with that, and we can adjust it. So what will happen is if I click one time, this will take a sample of 2 individuals from my population. So notice those 2 from somewhere in my block. It plots their mean, and then you probably see on your screen down below it tackles the medians. So I'm going to leave the medians off and just, again, look at the samples and then the means. So let's say I do it again. 2 more individuals, and there's their average. Okay, now let's say we want to speed this up a little bit. So notice it's taking 5 samples and plotting 5 sample means. Notice what's happening if I keep doing this. I keep on getting more and more X-bars. So what we're doing with the distribution down here is creating a distribution of sample means, or the distribution of the sample mean by plotting lots of different sample means, I should say. Now, right now it looks kind of sparse because we don't have a lot of points. What if we kept on doing this and kept on doing this? I could click this 1,000 times. Usually it just plops them down and shows you what the picture would look like if we did 1,000 samples of 2 and plotted the sample means. So this is an interesting graph. And notice if you compare this graph to the original graph, it's a much different shape. We would say the underlying distribution, this first one, is uniform, whereas if I had to classify the distribution of the sample mean, well, it's not a perfect bell shape, not a perfect normal curve, but it's, I would say, closer to normal than it is to uniform. Maybe I wouldn't quite say, hey, let's approximate it with a normal curve quite yet, but let's do a different example. Let's say I reset this and I change the sample size to maybe 5. So let me illustrate the difference here. This time, when we do 1, it takes 5 individuals from my population, averages those 5 together, and plots the mean. Let's do it again. So 5 more individuals, plots the mean. So let's speed it up. So 5 numbers get averaged together to create 1 X-bar. Then we're creating a bunch of X-bars and a distribution from those X-bars. All right, so let's speed it up. Ooh, this looks even nicer, right? So I would definitely say this looks approximately normal. Let's reset this and do a sample size of 10. Right, so just to illustrate with one time, I'm taking 10 individuals, averaging their numbers to get 1 sample mean. Then if I did it 5 times, that's 5 sets of 10 individuals. Ooh, notice that X-bar stacked right on top. That doesn't happen too often unless we repeat it a bunch of times. So you can see this is going to be time consuming if you were going to take these samples and watch this happen. Let's skip to the 1,000 after this one. Ooh, okay, so it looks even better. So just as one last illustration, say I want 30. And reset this. If I do it one time, notice that my applet was nice enough to go ahead and just put those 30 and do the X-bars, not make us watch. See what happens with the 1,000. So notice what happened. This looks more bell-shaped, but the other thing you might have noticed is these distributions in green kind of shrunk. The first distribution with sample size of 2 I'm just going to skip to the 1,000. Notice was very spread out. Sample size of 5, the 1,000 times, kind of squeezed in a little bit. We don't see as much out here and at the top. Okay, so contrast with my 10, 1,000 times, and then my 30. So this is interesting. As my sample size goes up, we're going to refer to the sample size as n. Notice the spread goes down. And the bigger our sample size was, the smoother this became and the closer it looked like a normal curve or a bell-shaped curve. So what I want to encourage you to do is play around a little bit with the different distributions. You can choose a skewed distribution and do the same thing. You could start with a sample of 2. Right? Ask it to do several samples, do 1,000. Same concept. Right? And you can change your sample size, see what happens. You can also, if you go to the top, choose the continuous custom. This is actually a fun one. What it allows you to do is take your cursor and draw a distribution. So maybe something that has 2 modes almost, and then you can sample from there. Okay. Uh-oh, mine went away there. Okay, so this app gives you, or this applet gives you the ability to change a lot of things and see the results. So play around with that, but what I want to do is summarize some of the things we saw with the uniform distribution. So what I want to do is have us compare 2 ideas. There's the concept, first of all, of a sampling distribution, where we are looking at the possible values of a statistic when we're just taking a sample. But then in Chapter 8, what we're introducing is the idea of the distribution of the sampling mean. In other words, not just looking at the possible values of the statistic and creating a histogram or a plot of some sort, but taking a look at a plot of the sample means or the x-bars. So this second definition is the new part in Chapter 8. The sampling distribution is the plot of the x-bars that's created from sampling from the population and then creating x-bars and then plotting. So a little bit more complicated. Let's go ahead and summarize what we learned from our applet. If we ask what we can take away from this, what we want to emphasize is that the sample mean, this x-bar, is a statistic in and of itself, meaning that if I take a sample, your friend takes a sample, and another friend takes a sample, you get different values. Therefore, when we're simulating on the applet, we get different values that all come together to create a plot. The values change depending on the sample, meaning if I repeat the activity, things are going to look slightly different. So then when we describe the distribution, we're going to give the shape, the mean, and the standard deviation. Here, the first thing we're going to tackle is the mean and then the standard deviation. I pointed out that when we were looking at the width, we saw that as that sample size increased, the width actually decreases. That's actually going to be summarized by our standard deviation. Here, the standard deviation of our x-bar shrinks as your n gets bigger, and it shrinks according to this formula. You would pronounce this sigma sub x-bar equals sigma divided by the square root of n. Here, this original sigma, this part, is our population standard deviation, n is our sample size, and then the whole thing together is our new standard deviation. The other thing that we saw that was maybe a little bit harder on the uniform is that the graph kind of stayed centered. This has to do with our mean. So the mean of our sampling distribution is going to be the same as the population mean from our underlying distribution. So we'll pick up with this concept in the second video for 8.2, or 8.1, excuse me.